Welcome to the presentation on software design and language impact. Today we will explore how different programming languages influence software design, architecture and overall development. In software development, the choice of programming language plays a significant role in shaping the design and functionality of a system. For example, languages with static typing such as Java or C++ encourage well-defined architecture and help catch errors at compile time. On the other hand, dynamic typing languages like Python and Ruby prioritize flexibility and fast development, but at the cost of potentially more runtime errors. Similarly, languages like C and C++ offer manual memory management, giving developers greater control, whereas languages like Java or Python handle memory management automatically through garbage collections, simplifying development but adding some performance overhead. When it comes to concurrency, languages like Go and Rust have built-in support for handling multiple tasks simultaneously, while others like Python rely on external libraries to manage concurrency. Different languages of software have different needs, and language choice is critical. For system software like operating systems and device drivers, languages like C and C++ are preferred due to their low-level capabilities and control over hardware. For enterprise applications that require scalability and robustness, Java is a popular choice due to its portability and strong typing. When it comes to web development, JavaScript dominates the front end, and with Node.js it also powers the backend. Python and Ruby are also widely used for web applications due to their simplicity and extensive frameworks. In data science and machine learning, Python has become the go-to language because of its rich ecosystem of libraries like TensorFlow and Pandas. For embedded systems where performance and direct hardware interaction are crucial, C and C++ continue to be the dominant choices. Design patterns, which are reusable solutions to common design problems, are influenced by the features of the programming language. Object-oriented languages like Java, C++, and Python encourage patterns like singleton, factory, and observer thanks to their support for classes, inheritance, and polymorphism. In functional programming languages like Haskell or Lisp, patterns like MapReduce are more prevalent as these languages emphasize immutability and the use of higher order functions. Modern concurrency languages like Go make use of patterns like the Ocar pool and publisher subscriber to manage multiple tasks concurrently using lightweight Go routines and channels. Object-oriented programming languages are built around the concepts of objects, classes, inheritance, and polymorphism. One common design pattern in OOP is the factory pattern, which is used to create objects in a flexible manner without specifying the exact class of the object to be created. This is particularly useful in Java, where object creation is often abstracted through interfaces and factory methods to promote loose coupling and easier testing. Functional programming focuses on immutability and the use of pure functions. The MapReduce pattern, popularized in languages like Haskell, Lisp, and Python, is a prime example of functional programming in action. It involves applying a function to each element of a collection, then reducing the result to a single value such as the sum or average. This pattern is particularly effective in processing large datasets in parallel, which is why it is commonly used in distributed systems like Hadoop. Concurrency is a key consideration in modern software design, especially in high-performance systems. Languages like Go have built-in concurrency support through Go routines and channels, making it easy to implement patterns like publisher-subscriber and worker pool. These patterns allow multiple tasks to be performed in parallel, improving the efficiency and responsiveness of applications, especially in systems handling many simultaneous connections, such as web servers. Maintaining and extending software systems requires careful consideration of the language features. Readable and modular languages like Python make it easier to manage and update code over time. With strong community support and well-documented libraries, developers can easily extend functionality without breaking existing features. Flexible languages like Python and Ruby also allow easy integration of new modules or third-party libraries, making them ideal for rapidly evolving projects. When selecting a programming language, developers must weigh performance against productivity. High-performance languages like C and C++ provide fine-grained control over memory and processing but require more effort to handle memory management and concurrency. In contrast, languages like Python and Ruby emphasize rapid development, allowing developers to quickly prototype and iterate through though a potential sacrifice in performance. Additionally, long-term maintainability should be considered, with languages like Java and C# offering strong ecosystem support for enterprise applications, and Rust providing long-term safety for system-level development. To summarize, the choice of programming language profoundly affects software design, maintenance, and extensibility. By understanding the strengths and limitations of various languages, developers can make informed decisions that ensure the success of their projects. Thank you for your time and feel free to reach out if you have any questions or need further clarifications.